a great feature of Mathematica is that many quantities that you enter, many of the commands that you can give it, can be formatted in exactly the same mathematical notation format that you use when you're taking notes, that you see in textbooks, that instructors use on the boards when they're writing expressions. And I think it goes beyond simplicity. I think it actually helps you understand better what it is you're doing in Mathematica, and I really encourage you to employ that. And that's as opposed to having to use English language computer commands and having to use inline notation for a lot of the mathematics that you enter. I'm going to give you a few examples here and talk a little bit about just a couple of the ways that you can do this. There's actually several different ways that you can approach putting in mathematical format commands in Mathematica, and I'll give you a couple ideas about this. So the first thing I'm going to do is I'm going to clear Mathematica. I've already talked about this in a different video, so you can pay attention to that. And then I'm showing you here just some of the examples of different mathematical formatting that you can use. So for instance, I can use Greek letters, alpha, beta, gamma, so on and so forth, capital and lowercase. The one thing you need to be aware of is that the Greek letter pi is different than all the other Greek letters. That is interpreted as the exact numerical value of pi. All of the other Greek letters can be used as variables. You can write exponential notation in exactly the way that it's written as 1.602 times 10 to the minus 19 is the example I have here. Mathematica understands the concept of infinity, so you can use the infinity symbol, the Euler's number E, the imaginary number I. It understands all of those, and you can put those in as those quantities in expressions. You can do definite integrals, so you see that I've got a definite integral here with limits from 0 to 2 pi or 0 to infinity. That is something that you can do. You can put in fractions in the normal mathematical notation that we use when we're writing fractions, with a horizontal bar and a numerator above and a denominator below. You can put in square root symbols. All of these are different notation rules that you can use, and the important thing is that this is not just formatting. These are executable commands. So for instance, I will execute this integration, and Mathematica understands that this notation is an integral, and it will perform the integrations for me and give me the results for those integrals. And again, I'm defining some Greek variables, beta and gamma, and I can evaluate those, and Mathematica will in fact take those as commands and execute those as commands. So again, this is a very, very powerful idea. So and I urge you to use this as you're entering commands in Mathematica. Okay, so there's a couple different approaches that you can use in order to really exploit all of these different input formats, these valuable, useful mathematical input formats. The first is to use palettes, and so what I'm going to do is I'm going to go up to my palettes tab, and I'm going to go down. I don't like the basic math assistant. There are some of these that you can use in there. I actually prefer to go down to Other and use the Basic Math Input palette. And here is what the Basic Math Input palette looks like. And I'll blow that up for you so that you can see that. And you can see, for instance, here is the fraction. If I want to enter a fraction in normal mathematical notation, I would enter it like this. If I want to enter a square root, I can do this. If I want to do an indefinite integral, I can use this. Or a definite integral, I can use that. The numbers pi, e, I, infinity. There's a conversion for degrees to radians, which uses the degree symbol. That's really convenient. Here is the multiplication that we've talked about, the Greek letters, and so on and so forth. So those can be entered using the basic math input. So let me come down here and just show that if I want to do an integral, this is what it's going to give me, and then I fill in the boxes for the lower limit, upper limit, the integrand, and the differential. All those boxes are there. I just fill them in order to make the integral command. Okay, so that's certainly one way to approach it, but there are actually entry shortcuts, and if you're using Mathematica even more than just a very little, some of these entry shortcuts may be a better way to learn how to use this mathematical format. So I'm going to put the palette away, and there's two primary ways that I'm going to show you for some of these commands. The first is escape keystrokes. So the typical escape keystroke requires 3 keystrokes. You hit the escape key, then you enter another key, and then you hit the escape key again. Some examples of things that you do with the escape key sequence are entering the Greek alphabet, alpha, beta, gamma, gamma, delta, epsilon, so on and so forth. Pi is again using escape keystrokes. Also integrals, you can enter those integrals that I showed you, the multiplication symbol as opposed to the asterisk, actually using the time symbol as the cross. You can enter that. Infinity, EI, those can get entered with the escape sequence. And then the second one I'm going to show you is the control sequence, and the control sequence is you hit the control key and then a second key, and that's the way we're going to get the square roots, exponents, and fractions. And so those are some of the things that I'll show you. So let me go back up here and show you, using those different approaches, how I'm going to do some of these things that I've identified here. So if I want to enter a Greek letter, what I'm going to do is hit an escape key. You see that once I hit the escape key, I get those 3 vertical dots. That shows me that it's waiting for some more input. In order to enter the Greek letter alpha, I'm going to type an A, and then I'm going to hit the escape key again, and you see that I've gotten the Greek letter alpha. And I can get the Greek letter gamma, capital Greek letter. I'm going to do Shift G for a capital G, and then I'm going to hit escape again, and you see that I get the capital letter gamma. Let's do pi. I'm going to do escape P and then escape, and I get pi. So those are the escape sequences. For those, let's enter some of these quantities down here. I will enter my 1.602. I'm going to hit the escape, and then I'm going to shift and my 8 key, which is the asterisk. I'm going to enter the asterisk, and then I hit my escape again, and that gives me the time symbol. Then I'm going to go 10, and then in order to get the exponent, that's a control sequence, so I'm typing the control key, and then I'm hitting the 6 key, which has the carré at the top, and you see it gives me the exponent box. Now I can enter minus 19. Okay, so I used both an escape sequence and a control sequence in order to enter these. Let's go ahead and escape, and then for E, I'm going to do EE. I have to do the double E, and then escape again, and that gives me the numerical value for Euler's number E, and the same thing for the imaginary number I. I hit escape, and then I, and then escape, and I get the value of the square root of -1, the imaginary number I. Let's enter some integrals here. I'll show you how I'm going to do that. So I'm going to use escape, and then DINTT, escape, and you see that I get this integral format in my typical mathematical notation. I can then enter a 0 down here. I can enter a 2 here, and then I'm going to do escape, P, escape, and that gives me a pi. I'm going to do an escape. I want Euler's number here, so this is EE, escape, and then I'm going to do control and 6. That above the 6 is the carré, so that raises my exponent up. I'm going to do escape, I for the imaginary number escape, and then K, and then X. Then I'm going to do a sign, K, X, and then I go into the box and I do a dx, and I can evaluate. The only difference that I have in the next integral, the only thing I added here is that I did infinity, and my symbol for infinity, let's delete what I put in there, and I'll show you how I'm going to get an infinity in there. Escape, INF, escape, and that gives me what Mathematica understands as infinity, and now I can execute that, and I get square root of pi over 2 for that integral. Additional thing that I'm going to add down here is the fraction, so I'm going to enter my beta, which is escape, B, escape, that's the escape sequence, equals, and then I'm going to do a control sequence, control and the slash key, and you see that it sets me up ready to put in a fraction in standard mathematical notation format, 0.8c divided by c, right? And then in order to enter this, escape, G escape, that's from my gamma, and that equals, let's go ahead and put in my fraction, so again that's control slash, and then I'm going to put a 1 in the numerator, and then in order to get my square root, I'm going to use a control sequence, control 2, control and the number 2, and that gives me my square root, and we'll put in 1 minus escape, B, escape. Then I'm going to do control 6 for the exponent, and that gives me 1 minus beta squared, and I can execute all that. Okay, so the entry shortcuts are what I just showed you for escape keystrokes, where you do escape, then another keystroke or several keystrokes in here, and then an escape, and then that gives you a number of these Greek alphabet and some other mathematical quantities, and then control keystrokes for square roots, exponentiation, and fraction. Those are important ways that you can actually enter quantities as commands in Mathematica in order to put them in standard mathematical notation format. And to show you again, I'm going to pull up this palette. How do you determine what some of these keystrokes are? If I go back to that basic math input, if you've forgotten some of these, you can find them again, by keying over pi, and it shows you the escape sequence. You see that it shows me escape P escape is the escape sequence for pi. For E, escape EE, the two E's for E. Escape INF, escape for infinity. So you can go back to this basic math input palette and you can remind yourself of those escape sequences. You can find information about escape sequences and control sequences in the Mathematica help documentation. The Mathematica help documentation is also somewhat complicated, just like getting up on the learning curve on how to use Mathematica. And so I'm going to show you where you can, one of the places you can look in the help documentation for more information about these. For escape sequences, look in letters and letter-like forms. So search on that in help, letters and letter-like forms. And in the Mathematica help documentation, there's some pages that look like this, letters and letter-like forms, and you see that there are a number of things that you can find in there. So if we look at Greek letters, you'll see that for the Greek letters, it shows me what the Greek letter is, alpha, and then here's the escape sequence I used for alpha: escape A, escape, beta, escape B, escape, and so on and so forth. I can also find those special quantities that I've used, the units and letter-like mathematical symbols. I can show you those. And so, for instance, it shows me that for Euler's number, escape EE, escape. For the imaginary number, escape II, escape. That's a way to find some of these escape sequences that I've showed you. And then for the control sequences, in the help, search for entering two-dimensional input. So that's what I've called that mathematical notation with fractions and exponents and square roots. What Mathematica is calling that is two-dimensional input. So we're going to search in the help for entering two-dimensional input. Here's the window that comes up, and you see that it shows me that I want to make an exponential notation, x to the y, and it does show me eventually here that I'm going to take x and then control and the Carré key or the 6 key, and then y, and then that's the control sequence for that. If you look further down, it also shows me that that's the control sequence, how to do the control sequence for square roots. Here's the control sequence for fraction, x, control, and then the slash, and then the y shows me how to do that, and the control sequence for a square root, control and then at or to. All right, control and 2 gives me the square root symbol, and then I enter into that square root the quantity that I'm taking the square root of. So those are the places to look and help for reminders about how to do some of these things. And there's a lot more. There's a lot more that you can do with the escape sequences and the control sequences than what I've showed you here.